the screen. So first of all, here is the CoCoSim GitHub repository. Usually we have all NASA tools that are developed by our group in the same organization, NASA Software VNV. So I recommend to go to this organization, because I assume that if you write just CoCoSim, you will find another version in GitHub, which is CoCoSim organization, and that's an older version of CoCoSim. So I recommend just to go to the NASA's SWVNV. So NASA SWVNV and then CoCoSim. So here where we can get the source code of CoCoSim, and there are two options basically to install CoCoSim. It's even you can go to the release tab, and there are some releases here where you have a zip folder, and where you can, so it's this zip folder, CoCoSim v1.2 zip. It's not the source code, just you can download that zip. What contains it contains the source code and also some libraries that we don't have in the source code. It's like in this zip folder we copied everything the user will need except the binaries. So this is the first version, is because we use some libraries from GitHub, from other repositories. One from CoCoSim Iowa. So Iowa has its own, the University of Iowa has its own version of CoCoSim, and we developed some common libraries together. They called the internal representation libraries. I will explain to them later. So I copied them also in this zip folder. So if someone wants to use the latest version of CoCoSim, which I recommend as well, you can try the master branch or the develop branch. What you need to do, you can clone the code somewhere in your repository. We can even do that if we want. So I will open a terminal, create some documents and make it your demo, cd demo, and let's git clone it here. Clone. I will also open MATLAB. So once we are in the CoCoSim folder, there are missing libraries. So this is the source code of NASA, of CoCoSim, and there are missing libraries. And CoCoSim cannot start working just from this source code. We need some external libraries that I told you that we have it in the zip folder. So how to do that? We have two steps. We need to run MATLAB and go to, my MATLAB is starting very slow. So we need to install things by MATLAB. So there are two things to install: MATLAB files, external libraries, and binaries. What I mean by binaries is the third parties model checkers like Kind2, Z3, all these solvers that we need for verification. So here I will remove my CoCoSim that I use from the path. So when I started the CoCoSim, when I started my MATLAB, CoCoSim already started automatically, because I added it to the bash file of MATLAB, which I recommend if you use the same repository for CoCoSim. You don't want to type the command start_CoCoSim every time. You can add it to a startup script in your MATLAB path. I can show you how to do that, but I will first of all, let's so now MATLAB is started. It's still busy.
So what's the latest version of MATLAB that you've tried, like, you know that things work with so far?
So personally I use 2019b. I know clients and users that use 2020. So we try to keep to support 2017 and above. So usually any user with 2017 and above should not have a problem. That's a good question. So let me open startup file to command start CoCoSim. And so here in the startup file, you can add it in your MATLAB. In documents, you have MATLAB folder. Always when you install MATLAB in Mac OS or Linux, you have a MATLAB file, MATLAB folder in your documents, and you can just create a new startup file, and anything inside something called startup.m will be run. So usually we'll just, I recommend do that. You can add the path to automatically start CoCoSim. So, and also if you have something, so for example, this command, it adds to MATLAB path some binaries. For example, here I add my local bin folder to the MATLAB path. For example, you have a solver like YESYS2 or Z3, and Kaintu should able to detect these solvers automatically. So when you add this set in environment path with this new path, which is the old path concatenated with your user local bin, you should be able to tell MATLAB, okay, these binaries also are included to your path. This helped me to not be worried about EAS's installation. So CoCoSim debug is to get debug messages, is for CoCoSim developers to know exactly what is the MATLAB crash, where MATLAB crashed. You can trace back what's the cause of the error. And CoCoSim force, it's an old command, force code generation. Okay, so basically now I commented my CoCoSim, but we created a folder called demo, and inside the demo we should have CoCoSim that I just cloned by the terminal. And inside that CoCoSim we need to go inside and type start CoCoSim. What this command is, you should all with any new MATLAB session, you should run this command. What it's doing is making sure that you have the external libraries, and making sure that the CoCoSim is added to the Simulink environment tool menu. So basically, it will add the CoCoSim menu in your Simulink environment. Whenever you open a Simulink model, you will see the CoCoSim menu below the tools menu. I will show that later. So now I will start again CoCoSim, but now it's not my CoCoSim, but the CoCoSim I just cloned from GitHub. And you can see that it's using Git to clone external libraries. So in order to be successful to start CoCoSim, we need to have internet connection. It will be good to have the internet connection while doing this. So without an internet connection, we cannot clone the external libraries and copy them to the right folders. If there is no internet connection, then you need to start reading this install CoCoSim lib, and this is documented in the installed documentation. But you should go inside and see what I'm copying into what destination to do things by yourself manually. So sometimes people have, even they have internet connection, but some people from the industry, they have some limitation using Git and Git clones, and they have some proxies that doesn't allow them to do stuff. So if you have problems with that, you can just open the install CoCoSim lib and read what we are doing, instead like manually do things. Like here is the source files of the CoCoSim of Iowa, and here is the destination of where I should put each source file to destination. But hopefully no one needs to do that manually. Hopefully everyone has the internet connection and able to get things. So here, this starts CoCoSim now, copying files. You see that it copied all external files. There are two repositories. There is the CoCoSim of Iowa that copy the standard libraries that we developed with them to the right destination. And it copied some external libraries that I use personally from my GitHub. And now I see that it successfully copied everything. So now we have the external libraries, and how you can know that external libraries are there, you can just open the example folders and you see that there is examples. So these examples are from the Iowa University. We didn't develop them ourselves. So if you see this example contract folder, you are sure that this script is well run. So now the second script after start CoCoSim, you need to make sure that you have all the binaries. So now if you open the tools folder, the verifiers, you don't see any binaries besides gkind. Binaries, if you have a Mac OS, then you need to have OS X folder, and if you have Linux, you should have Linux folder. To do that, we go back to the terminal, and we go to the scripts folder inside CoCoSim, and we run install CoCoSim scripts. So this one is installing binaries. So start CoCoSim of MATLAB is installing or copying the libraries, the MATLAB functions, and the MATLAB libraries required by CoCoSim. And this script is installing binaries for you. So for example, here it says, okay, I need some library called disutils from Python. Well, I figured out that, in fact, my Python path is making problems. I just unset my Python path so he can detect earlier versions of Python. And now he can be, the script can detect that I have the right Python and stuff. So this script is taking a lot of time because it will try to install many tools for you from scratch, like it's in Z3 using OPAM, Kind2, and many stuff. I will not do that, but so for example, I know that I have already CoCoSim in my laptop, and I already did this for my CoCoSim. So I will just go to my demo and CoCoSim, and I will copy the old CoCoSim tools folder to this new CoCoSim. GitHub CoCoSim. So it's always in tools, verifiers, and I have OS X. I will ask him to do this to my own tools verifiers. I need to have, it's a repository. So now if I check the tools verifiers, I have OS X, and if I check OS X, I have binaries. And if I check binaries, I have many binaries. So let me go back to make sure that they are binaries. So I will check that they are all executable files. So -x for Kind2, for Lucer-C, and for Morningstar. So if I stop this one, yeah, you can keep this one installing from scratch all the binaries that you need. But I will stop it and run the install CoCoSim again. What it will do is, like, it will say, okay, now you have Z3 successfully installed because I copied it myself here. And yeah, it will say Lucer-C is successfully installed and Kind2 is successfully installed. That's what it will say. And we are good now to run CoCoSim because now we have all the binaries here, Kind2, Lucer-C. That's the two main ones I need, Kind2 and Lucer-C. Z3 are used by Kind2, and Yace is used by Kind2. Now we can try to run examples to make sure that the installation of CoCoSim is successful. So to do that, I can run any example, maybe the absolute example, and see if it is successfully running.
So just to repeat here, the corresponding folder for the binaries for Unix should be named Linux, right?
Yes. So okay, you will have, under the verifiers, you should have a folder called Linux. Okay. And you should have a bin folder as well, similar to OS X. It just, instead of OS X, you will have Linux.
Mm-hmm. Okay.
And if you have, let's say you have your own path of Kind2, you have your Kind2 that you install yourself, and you don't need, you don't wanna copy it to this folder exactly. You can go to the tools config file. This one is the configuration of tools. And if we open it, you can see clearly you can overwrite the path to your preference. So here we have all the tools like Luster-C, Kind2. So for example, I have Kind2 in my user bin local. So what I will do, I will tell him it's in /user bin local, and I will comment this one. So now I have put my, now I need to do Kind2. It's the binary path. So now I have exactly overwritten my configuration of CoCoSim. And you can put your customized path for all the tools if you want. In this case, you don't need to do any install CoCoSim script that we run here, and you don't need to copy them to your tools folder because I use these global variables to tell me
binaries that are automatically.
Sorry. Go ahead, Andreas.
The binaries that are automatically installed, are they always the latest release of the corresponding binary, or are you downloading specific versions?
That's a good question. I use the latest. I think for Kind2 I use the develop branch. I can show you also how to modify that. That's a very good question to show people how to modify that. So where is the script that runs the installation script? It's here. And if you go to the install CoCoSim, open as a text, you can find exactly what is the Kind2 GitHub URL and what is the branch develop. So for example, we may be interested to run the master branch. Maybe you should come here and change it to master. For Luster-C, I use the unstable because it's the latest version of Luster-C. So develop is the latest version of Kind2. Master is well behind the develop, like a year behind, and that's very old branch. They didn't update it for a long time. So maybe I recommend using the develop. I recommend just keeping this as it is, but you can just choose which version of which branch you want. So it's in install CoCoSim _CoCoSim script. That's a good question. So for people that want to use their own path, come to tools _config.m. You can just do open tools _config, or you just go to tools folder and you find it here. So now we have, I think we finished the installation process. We can run an example. I think I opened some example. Here the absolute. So here is the absolute. This is the subsystem of the absolute example. What is doing is just saying that if the input is positive, then the output is equal to the input. If not, then do -1 of the inputs. So the output should be it should be like the absolute value of input. But there is a problem here, that the input is like a machine integer type. So if we simulate and ask Simulink to give us some information about signals, my laptop is very slow, so bear with me. Maybe I should stop things. So here now it's compiled. While the model is compiling, you can ask Simulink for debug information. So this is the new Simulink version of. It's so different. It's totally different from 2018 and 2017. The Simulink environment. You can ask to show the data types of signals. Oh, I have problems in my MATLAB. I don't know why. Ah. Examples, contracts. Great. Let me check what is taking my laptop so much. MATLAB, Skype, Google Chrome. Most of it is Skype. Okay. But I can just finally it showed up. So I can just explain without showing that base data type. Okay, so now I ask Simulink to show the base data type, and I can see that it's integer 32 bits. And so the problem with integer 32 bits, if you do -1 of integer 32 bits, the int min, then it says the int min, so which is basically minus of, if it was int 8 minus 128, if you do -1 multiply minus 128, it will be -1 because it overflows of 127, and it goes back to minus 128. So the outputs can be negative if the input is the int min of the int 32. So this is what is called contracts, and this is where we put our properties that we want to prove and verify with CoCoSim. So first of all, where is CoCoSim? Where can you call CoCoSim? So in the latest versions of MATLAB, the tools menu is hidden here. So tools, CoCoSim, and you can run proof properties. So before going to that, I should explain what is this block. And this is an important block because it's the one that you specify your requirements. So for example, in this contract, we have no assumptions, we have 2 guarantees, and we have 0 modes. So if we click in the validator block, we have 0 assumed ports, 2 guarantees, and 0 modes. What does it mean? It means that we don't have assumptions on the inputs, we don't have any preconditions, we don't assume anything about the input, but we want to guarantee something. We have 2 properties to guarantee. We don't have modes. I can explain modes. If someone is interested to know modes, he or she can go to Kind2 model checker documentation, and they can learn about contracts and CoCoSpec. So here the first property is to prove that the output is always greater than 0. And we know this property is not true because if the input is int min, then the output should be negative. The second property is it's it's the absolute of input should be equal to the absolute of output, and also is this not true because the output this absolute value is using what? Using signal attributes. absolute of minus, I should check. But this example from Iowa, I just want to demonstrate that one of the properties or both should not hold because we have the int min situation with the output. How we can create this contract? Usually if we go to the library browser, if CoCoSim is well installed, we need to find it there. But sometimes with whatever version, it depends on the versions you have, you may not find this in the Simulink library. So I recommend just opening the lib folder of CoCoSim and open the contracts or CoCoSim libs. Contract libs contains all the blocks of the contracts. It's opened here, and we can see the contract libs in the libs folder. It contains the contract, the validator, the guarantee, the assume, and the modes. So if you just copy this one, copy paste, and then go back to this file and my method is another time is freezing. Now I copy this from my CoCoSim library and I can use it. So I copied it twice. I can rename the inputs, the outputs names. I can add more inputs, add more outputs. It depends on your component. The contracts is attaching the inputs to the inputs of the subsystem, and the outputs to the outputs of the subsystem. Both outputs and the inputs of the requirements are inputs of the contract. So this is called an observer. It's like a synchronous observer, which is it tries to observe the execution of the subsystem. For a given input and the computed output, we can prove things. So both outputs and inputs are inputs for the contract. The output is just a valid flag that says if the contract holds or not. So the contracts in the beginning is instantiated with one assume, one guarantee, and two modes. You can go and say, I don't have a assumption, I don't have modes. Maybe I have 3 guarantees. Then this will change, and then I can remove the modes block. I have 3 guarantees. I can remove the assumption, and I can copy the guarantee 3 times. And inside each guarantee, I can add properties. I recommend that you can add all your property here. Describe your property, for example, that the output is greater than 0. We can add input here that says it's an output. My MATLAB is slow. Okay. We can call it output and a relational operator to say that, or maybe compare to constants, to compare it to constant, compare to constant. And I can give the constant 0. Now I tell it that it should be greater or equal to 0 for now. You may notice just I typed the name of the block here, so I don't need to go to the Simulink library and drag it. So you just need to type somewhere in any empty area, and you can type the block type, the name of the block, and Simulink can just instantiate it there. So I can link the output here. No need for input maybe for this requirement, but maybe we need it for this one or this one. And you finish your properties and you specify them. So that's how we created this one. Now you have your properties. You can call CoCoSim. I need to save it. So first of all, before calling CoCoSim, there are many configurations of CoCoSim, like many preferences and many settings that you need to make sure first that you chose the right configuration for your right use. I will go over some of them. So for example, here we have two compilers, NASA compiler, the one that we developed, and Iowa compiler, the one that exists in the GitHub, the CoCoSim version I showed you earlier. That's a very old version. I don't recommend using Iowa compiler. It's not updated and it's not validated. So I always make sure that always it's in the NASA compiler choice. So if you choose NASA compiler, there are some of the preferences. So I noticed that the menu is different because I use the master branch in what I can do is I can ask this if you just want to make sure you want to try to get the latest version of CoCoSim, you may just do git pull, or you may be changing to the develop branch. So I will ask to check out the develop branch because I just made some changes yesterday, and I noticed that they don't exist in the menu. So now I can check if we have preferences. Yeah, we have now two preferences: NASA compiler preferences and NASA compiler abstractions. So for NASA compiler preferences, you want to skip things. Like when you run CoCoSim at the first time, it tries to say if there is a block that we don't support, and you are running the same model again and again. You don't want to CoCoSim telling you, oh, this model is supported by CoCoSim. You may just ignore this compatibility check. So you may set it as true. So next time we will not tell you that it's already supported. Also, I recommend keeping this true, so it skips pre-processing. I will explain what is pre-processing later on. Skip looser code optimization. The looser code we generate is optimized, and sometimes optimization takes a long time. For you, you don't need the optimization. You need each block as a separate looser equation, and you don't want to optimize, and you want to keep full traceability of the translation. So that's up to the user. Force code generation is something that if there are errors, most of the time CoCoSim will stop the execution. But you may need just to have something generated for your model, and you may just manually change the looser model, maybe add the missing parts by yourself. So maybe you may be interested to force the looser generation, and we can do our best efforts to generate as much looser code as we can, and you may just go and fill the gaps manually. Skip stateflow parser check. So stateflow is state machines and states and transitions have MATLAB actions, so they are textual actions. Now we developed a parser for these stateflow actions, and we are making sure that what we parse is the correct thing. So this stateflow parse will go over each transition and each state and telling you this is what we parse, is it correct? And maybe sometimes it's time consuming. So if you do it the first time and you are happy with our parsing, maybe you should disable it next time. You don't need to ask you every time. And that's very important for someone that we keep asking the same thing. We may improve it in the future to remember the name of the model and the user choose everything true. Then we may not ask again. But for the moment, you may just disable it if you are sure that we pass in correct actions. So the abstractions is related to formal verification. So informal verification solvers, they don't support a lot of things. The solvers we are using, like Kind2 model checker is using Z3 and CVC4 and other solvers, they don't support, for example, trigonometric functions. So if in your model there is like an SQ root or cosine or sine, we abstract them. We tell the solver that, for example, cosine is between -1 and 1. That's very simple abstraction. And we have a more precise abstraction using a lookup table. What means it's like an interval piecewise abstraction. You say, okay, if the angle is between 0 and p4/4, then this output is between this and this. We just divided the pi over many intervals to make it more precise. But it's not that precise to have like an equality. It's just like giving you small intervals. So if you want to use more precise, you can choose this one. And this one is difficult because when you use this one, the lookup table for cosine, for example, it gives the Kainto solver more constraints. Instead of having one minus 1, now he needs to make sure that it's more conjunctions for the solver, and the verification times is taking more time to prove things or find a counterexample. So try to play with it. Maybe keep it disabled the first time, and now you have a counterexample where the cosine of 0 is equal to 0, and doesn't make sense. Cosine of 0 is equal to 1. So you may just want to say, now let's try this one, because Kainto is able to find a counterexample very fast. Maybe if we give a more precise abstraction, it can find something more interesting. It can prove things, and it can find counterexamples that are nonsensical, but still you can play with it. So this is something to keep in mind if you have a counterexample that is very stupid, but you might want someone more close to what is expected. Unsupported blocks are automatically abstracted. So for example, if you have a block, we will not tell you for verification purposes. We will not tell you, oh, this block, we will tell you that this model contains some unsupported blocks, but we will still do verification, which means we just abstract that block with a black box, which means that block can generate anything, and we will still give you some results. But keep in mind of the report that we give you before the verification results. If we give you a report that's saying these blocks are abstracted, the counterexample may not be sensical. It may not be. It may not make sense. For example, we abstracted cosine or abstracted another block that we never supported. Abstract lookup tables for verification using breakpoints on tables. So this is I just added it last week, and it's very interesting because the way lookup table now is implemented is we give the concrete implementation of lookup table. We use interpolation, we use extrapolation, and we give you the implementation, the precise implementation of lookup table. But this precise implementation is a lot. There are a lot of nonlinearities because there are a lot of divisions and a lot of multiplications. And what we notice is that it's taken a lot of time to prove that maybe the lookup table outputs are within the range. So what we did is, instead of giving the concrete implementation of the lookup table, if the user chooses to enable this option, it will try to give just an abstraction of the lookup table the way that we did it with cosine. So for example, if the input is between these two breakpoints, then the output is between these two values. And that's a correct abstraction. It's over precise. So if my input is between this interval, inside this interval, then the output is inside this interval. And this is speed up our example by less than a second. We can have a counterexample less than a second, versus if we use the implementation, it says like 1:37 minutes. So it's very interesting. I recommend using that if your property is about proving that things are within some range. If you want to precise things, then disable it. If you want to know for sure what the y value is, then this abstraction may give you nonsensical counterexample. So it's very important for the user to understand what's happening here, because most of the time that I get some issues in GitHub asking why I'm having this counterexample. And I told them, yeah, your model contains cosine, and that's what's happened. Or your model contained ischios, and that's what's happened. It's abstracted, and while abstracting that block, we lost information, and we found a counterexample based on the abstraction, not the precise implementation. And that's very important to keep in mind. So the verification backend is the only one that is supported currently is Kainto. We are working to try to support Gkind, even if it is limited, and Zeusr, but currently only Kainto is supported. These are Kainto flags. I will explain composition in another chapter, composition analysis. The SMT solver, there are two, and they have different performance. It depends on your model. You may choose one of them and then try again with the other one. And this flag uses check assuming which we noticed that using this flag may speed up the process, speed up the verification time sometimes. Try to with it or without it again. So there are some settings here that the user can try different settings and see which one is the best for his or her model, for the user model, exact model. The local binary is currently is only the local is supported. There is no Docker support in NASA version, so keep that in mind. Don't change the local binary to the Docker. And the verification timeout is when you run kind2, you tell kind2 what time, what is the timeout. So if the verification spends more than some X timeout, X minutes, kind2 should stop. You are maybe not looking to look for more than 1 hour or more than 1 day. So here is no timeout for people that are patient and they want to wait as long as it takes. And maybe, so we have cases where it took like more than 1 day. So exactly, so we experimented with CoCoSim a lot and we have different cases. And so the maximum we can set is 120 minutes, but if you want more than 120 minutes, that just set no timeout. If you are like want to stop it, just stop the MATLAB execution with Control-C. Ignore this for the moment, and the verbosity is, for example, if users want more debugging messages from CoCoSim, if they are familiar with MATLAB and they are familiar with CoCoSim, like CoCoSim developers, and they want to have more messages than the normal user should have. Reset preferences, if you wanna go back to what was as default preferences, you may change things and you wanna forget about what was the normal settings, and you wanna just go back to the default settings. So yeah, now we have our settings. We can just choose NASA compiler. We choose composition verification. I will explain that later. We choose the timeout. Maybe 20 minutes. Now we can just type pro properties. So now CoCoSim will be running and will run many. It's like a compiler, which is a lot of sequences, a lot of things that are executed one after one. I will explain them in details in our next chapter. So right now I'm just running CoCoSim for you to see if the installation works. That's the first chapter is just about installing CoCoSim, installing the external MATLAB libraries using stars_CoCoSim command in MATLAB, and installing the kind2 binaries using go to the scripts folder and running the install CoCoSim scripts. So that's it. We will finish with this chapter, and we will like wait until the verification results for this one finish. It's still running many stuff. I will explain to you exactly what's happening behind the scene in the next chapter, step by step, and we will go into details about how CoCoSim is developed and how CoCoSim is run, and what is formal verification and what is how things work. So here I got a message that telling me that this model is supported by CoCoSim, and what it exactly says is that this model may have some blocks that are partially supported, because the compatibility check doesn't tell you exactly that the model is 100% sure that is supported, but it tells you that all the blocks that is inside your model, we have seen them before and we support some version of them. And we don't know if they have some version we don't support, but that's what it's telling you. So here we saw that the kind2 give us a counter example. This is just the output of kind2. You don't need to read it. You don't need to understand what it's saying, because we bring back the results back to the user. So all these outputs from kind2 are hidden for the user, because I choose to have debug equal to 1, so I see everything. But the normal user should not see this. But finally, the normal user will just see the verification results reports. So the verification results reports are HTML format. It's telling you you have an subsystem that you wanted to verify, and the contract is invalid, which is this the red flag. And it tells you that you had two properties. The first one, guarantee output greater than equal 0, and the second one, the absolute value of input is equal to absolute value of output. If we go to the first guarantee, we have the counterexample displayed as an HTML format, and you can notice that this is the this is the int min of int 32. This is the lowest value, the smallest value of integer 32 bits, and that's why if you multiply it by -1, then you will have the same value. And we try to ask to prove that the output is always positive, it's always greater than 0. But Canto is able to tell you no. If you choose minus int min, then the -1 of that it's the same value, and that's a very interesting counterexample. You will not get that counterexample if you choose the abstract. For example, here example. I think. Let me open the examples again. Always the original model is never touched, and it's copied to something called _pp. And the _pp, we don't touch the original model, so we don't break anything for the user. So because we change colors and things, we make sure we copy the original model and we name it something else, and we do anything on it. So just to be safe that the original model is not altered or modified. So if you go inside the contract, you can see the counterexamples in different versions. If you double click in any guarantees, you can display the counterexamples as signals. You can display them as tables, as HTML tables, and even generate a harness model. What does it mean, generate a harness model? It means that there is another file that will be generated, and the inputs will be replaced by signal builders. And you can simulate the model and debug it. So here is the account example using signals. And if I do signal harness model, what will be do is just change this one with the signal builder with the counter example, and then you can debug the internal by yourself using the Simulink simulator, and that's very, very useful. I think I can stop here. Next time we'll learn more about the CoCoSim code and about CoCoSim architecture. Do you have questions about that? Anything I explained here, and Andreas?
Right. So regarding the abstractions that you have introduced, is there a way to browse through the abstractions themselves in some way? And like for example, you said about the cosine being abstracted to -1 to 1. Is there a particular place within CoCoSim where one can take a look at what kind of abstractions are?
That's a very good question. So next to your model, so here is the original model I tried to run. There's always it's always copied and called _pp, where we do verification and where we do a lot of changes. And then next to it, there is the CoCoSim output folder. If you go inside, you see that there's a folder for each model you will run in the same folder. So here we have the CoCoSim output absolute_pp, which is the folder that CoCoSim generated for this model. Inside you have the Lustre file, which is the implementation of this Simulink model in the Lustre language. We can explain that later in next chapters. And if you see that there is always not in this case, but if you use like let's say cosine, you will have a file called lustrec_math.lus in the same folder, in this folder. And inside that lustrec_math.lus, this is a library provided by CoCoSim. You can go inside, you will see all trigonometric functions there. And you can change the implementation, change the abstraction yourself. But you can change it for this particular file, and then you can run verification again. But if you want to change it for all the models in the future, let's say you find out a very precise abstraction for trigonometric functions, you can go to the my compiler. So here we are going to the next chapters in advance, but it's okay. So the source folder has the middle end, and the middle end has all the compilers that are supported by CoCoSim. So it has the Iowa that I don't recommend. It has our compiler, the NASA one. And if we go inside the NASA one, there is the lib folder that has all the libraries that we are using of Lustre files. So there is some conversion libraries, like if you convert integer to real, or you convert bool to integers. There is some kind2 lib. For example, multiplications and divisions are abstracted. We can open them. So for example, the kind2 times is the multiplication of x by y. We give some abstractions, like we give some properties about the multiplication. We give the neutral element, the absorbing property, the sign, and many properties that helps the model checker verify properties. We also have lucerc_mat, that the one I told you, Andreas, is this one. If you open it, you have many trigonometric functions. For example, you have arc cosine, you have sine, you have cosine, and this is just asserting that the cosine is between -1 and 1. There is another one called lucerc, a more precise abstraction. This one is the one you may change because it's more precise. If you change it here, then for any future CoCoSim, for any future model that will be run by CoCoSim, it's the one that will be used. So for example, cosine is abstracted by a lookup table. For example, if x is between 0 and the degree is between 0 and 0.45, then the output is between 0.9 and 1. And this is just a lookup table abstraction. It's more precise than -1,1, but it gives the model checker more constraints and may impact the verification time. That's the folder where. Is that answer your question, Andreas? Sorry, I lost you for 2 seconds.
Yeah.
Okay, perfect. Great. So let's end this session here because it's like 1 hour now, and we will film again the next chapter in a separate video. So thank you, Andreas.